So, looking at operations on functions, we did a little bit, you guys did a little bit of this last semester in Math 10 IB. We looked at what function notation was. You did some calculations with function notation. You did some expressions, so f of f plus 1, that kind of thing. Now we're looking at operations with function notation, with functions basically. Adding functions together, subtracting them, multiplying them, dividing them. Okay, so the 4 basic operations. So when we write equations of functions, they can be written either in terms of x or in terms of f of x. Okay. An equation is written, if an equation is written in terms of x, then we know what the function is. We could put it into our calculator and graph it. We could graph it on our own. Okay, so it might be a linear, quadratic, exponential, any of those that we've learned. It might be shown as y equals or f of x equals. So it's still function notation, but it's f of x equals something in terms of just x. If we're writing a function in terms of f of x, then that means we don't necessarily know what f of x is. We just know we are supposed to graph it or do some work with it. And so it's sort of a generalization of a function. Okay, so we use that when we don't know what the equation is. But maybe we're doing some transformations and that kind of thing. So it will have a y and it will have an f of x. This only has a y, once, or an f of x once. So y equals or f of x equals. This has both of them. So for example, y equals f of x plus 5. So that's saying y is equal to whatever the function f of x is that has to be given to you, and then you add 5 to it. Okay? So first thing is just a detective work here. Circle the equations below that are written in terms of x and name the type of function. So if you can name the function, then it's in terms of x. So taking a look at the first one, y equals x minus 3 squared. Hands up. What kind of function is that? Quadratic. So we know what it is. That means it's in terms of x. So we're going to circle that. Okay. Oops. And it's quadratic. Okay. Next one is y equals 2 times f of x plus 3. I don't know what kind of function that is. You'd have to multiply whatever f of x is by 2 and add 3. So that f of x could be a quadratic, it could be a rational, radical, I don't know. So that's not in terms of x. This one has an f of x, so maybe it's not, except that it's like this one. It's f of x equals, and this is linear. So this is in terms of x, because I know how to graph it. Okay, what type of graph it'll be. Next one's y equals, so I've got a y and an f of x, remember that? So that is not in terms of x. I don't know what f is. Yeah, maybe that's linear, that's going into f, but maybe f is a rational. So I don't know what that is. Next one is f of x equals, so there's just f of x, there's no y, so likely this is in terms of x. Take a look, 4 to the x. So 4 to the x, we haven't talked a lot about exponential functions, you'll do that in Math 30, but it is a type of function. You can enter that in your calculator and graph it, so that is in terms of x, and we call that an exponential function. And the last one is a rational function, right? You've done that here. Okay, so explain the difference between 2x plus 1 and f of x equals 2x plus 1. Well, this doesn't have an equal sign. no equal sign. So remember, if we have an algebraic statement like that, it's called an expression if there's no equal sign. So this is an expression, and this is an equation of a function. Okay, so we could graph the second one. So if f of x equals, in question 3, that's a quadratic, it's degree 2, determine the simplified form of each of the following. So you did some of this back in math 10, IB. So here, if we were asked to find f of negative 2x, that means you want to substitute every x in the original with negative 2x. So I'm going to use some color here so you can see what I'm substituting. But everywhere there was an x in the original, I'm putting negative 2 in, and then simplifying that. Following the order of operations, you have to do exponents, then multiplication, adding, and subtracting. Just make sure you're careful with the negative signs. Squaring a negative is a positive. All right, so next one, 2 times whatever f of x is, and then add 1. So order of operations says we have to multiply. So this is going to be 2 times whatever f of x is. So actually, I'll put that in red. Just give me a sec. Okay, so in the brackets will be x squared minus 3x plus 2. Okay, so you're not replacing x with anything. You're multiplying whatever f of x is by 2 and then adding 1. And then collect any like terms. Okay. Now, so basically you want to look, is the bracket in f replaced with anything? If it is, then you replace that everywhere there's an x in the original. If you just see f of x, but stuff outside, then you're not doing anything to the original function, you're putting the whole function in. So here, we just put the whole function in and multiplied by 2, added 1. Here, that's all. We have f of x plus 4. So we now replace every x in the original with x plus 4. So here, I would have brackets squared minus 3 times brackets plus 2. So I basically copy out the original, except everywhere there's an x. Uh-oh. Nope. I put x plus 4. Okay. Now remember, when you square a binomial, 3 terms. Give me gray hair. 3 terms when you square a binomial. It is not x squared plus 16. It's x squared plus 8x plus 16. And then get rid of the brackets in the next part. And then collect like terms. then last one, actually, we've already done part of it. So this f, oh my goodness, whoa, okay, hold on a second. Okay, so we have here, you've already done the f of x plus 4, so why not just substitute it in right away? That's what I would maybe recommend. You can substitute within, but it requires a fair bit of work. So if I were given something like this and I hadn't done part C, I'd probably do it on the side and then substitute it in. And then subtract 5. So then here would be x squared plus 5x plus 6. And then that's going to be negative 3x squared minus 15x minus 18, and then minus 5. Okay, minus 3x squared minus 15x minus 23. Okay, so that's a bit of review from Math 10 IB. Now we're getting into the operations. So just like numbers, functions can also be added, subtracted, multiplied, or divided. The table to the right shows the notation. So short form, we use brackets there. So bracket f plus g of x is the faster way of saying f of x plus g of x. It saves you a set of brackets, basically. Okay, so it does not mean that we're multiplying f times x and g times x. So you have to know the context of the question. If you were asked to do something like this, you would be given f of x and g of x. Can't do it if you're not given it, right? Whether it's in the form of an equation or a graph or a set of ordered pairs, but it doesn't mean that we're going to just distribute the x, because it's function notation. It's not a multiplication. Okay, and then this is subtraction. Multiplication, you can put a dot in between f and g, or just write fg. That means multiplying. And then dividing is usually in fraction form. We tend to stay away from the x as a multiplication now that we're dealing with a lot of variables. Because a lot of you, it looks like an x looks like a multiplication, or vice versa. So we use a dot or nothing. And then when we, later this week, learn about composition of functions, it'll be an open dot, an open circle in between. So it's going to be important to make sure that that's a closed dot like that. Okay, so let's do some work with this. So we're given two functions, a quadratic and a linear. It says determine a simplified expression for each of the following in terms of x and state any restrictions. So what is it defined for is basically what you have to think about. So f plus g of x means we're just adding x squared minus 9 plus x minus 3. Okay. Do you need brackets? If you're adding, you don't really need brackets. Okay, but I did to show that that's what you're doing. Adding each function together, collect like terms. You get a quadratic. So you started with a quadratic and you added a linear, and you still have a quadratic. Okay, that's always going to be the case. In terms of restrictions, well, think about it. A quadratic, what's the domain of a quadratic? And a linear. A polynomial function. Hands up. What's the domain of any polynomial function? It should be automatic. Yes. Yep. All real numbers. Okay, so x element of the set of reals for both. Okay, so that means we can add them together and it's still all real numbers. Okay, so there's really aren't any restrictions for that first one. Same for the second one, there's not going to be any restrictions because you're subtracting them, okay, for any values. Now G goes first, so that's x minus 3, and we're subtracting x squared minus 9. I do recommend brackets when you're subtracting because you have to subtract each term, and if you forget to change the sign, you'll get it wrong. Okay, so now when I get rid of the brackets, it's minus x squared plus 9. And then I like to show it in descending order of degree. Okay, that's proper form for a polynomial function. And again, it's quadratic, all real numbers. Okay, there's really, when you're adding or subtracting or multiplying, if both start with all real numbers, then you're going to end up with all real numbers when you do those operations. This one, we have to be careful about the denominator. Okay, so then here, multiplying, well, f is x squared minus 9, and g is x minus 3. So we're multiplying. We're going to end up with a cubic. Okay, a quadratic times a linear is a cubic. So do that, expand that out, and then descending order of degree. You leave it in simplified form. You'd only factor it if they asked you to. Or if you had to graph it or something like that, maybe. And then division, so that's going to be x minus 3 over x squared minus 9. Now, simplify that, right? So remember back to math 10, you're simplifying the rational, you want to factor everything that you can. Okay. And divide out common factors, x minus 3. Okay. So this one, in terms of our restrictions, the first ones we can have all real numbers. Here, remember back to math 10, you look at the factored form before you simplify anything. So here, x cannot equal positive or negative 3. Don't just look at the final answer. You want to look at the factored form before you simplify. So you cannot divide by 0. Okay, so those were for polynomial functions. Let's turn over to the next page. Now we're going to look at radical functions. Basically doing the same thing. You won't be able to simplify very much. Okay, there's not going to be a lot of like terms. Notice in this, we've asked you to state the domain for each of them. So this is a good review from last week. So who can tell me what the domain of f of x is? So what values of x is it defined? What's the domain? An inequality, so hands up. Remember, you can't take the root of a negative. So what values of x is it defined? Correct? Greater than or equal to negative 3. Yeah. So this here has to be greater than or equal to 0. So that's going to be x greater than or equal to negative 3. And then this has to be greater than or equal to 0. So what's that going to be? It's g of x's domain. Come on, you guys. I know this. It's straightforward. This? X is less than or equal to 3. Good. Just be careful of the sign, right? So you have 3 minus x greater than or equal to 0. You bring the x over. You get x on the right at the little end. So less than or equal to. Okay, so when we're adding these together, then f of x plus g of x. They're kind of close. If you factored out, oh, actually, they're not even close if you factor the radicals. There's nothing you can do to simplify that. That's all you state. Okay? Then in the right column, we'll use that for the domain. So here's where you have to be careful. Remember, we talked a little bit about it. So let's say we had y equals f plus g of x, and I wanted to find the value of f plus g of 1. Okay, so could you do that? Well, I'd put 1 in here. I'd get 2 plus, oh yeah, I can do that, sorry. I was looking at the wrong thing. Yeah. How about if I said find f plus g of 4? So put 4 in here. I would get root of 7. That's good. But if I put 4 in here, I'd get root of -1. That's not good. Okay, so 4 is greater than or equal to -3, but it's not less than or equal to 3. So whatever that number you choose has to satisfy both of these. So that's where you draw a number line. That's why we practice this at the beginning of the semester. We want to look at x greater than or equal to -3 would be this way. X less than or equal to 3 would be this way. And we have to see where they overlap. That's going to be the domain of our adding, subtracting, multiplying, and dividing. Dividing, we might have even a little bit more of a restriction. So, what is that? That's between, okay, look. Okay, so that's between -3 and +3. Okay, I'm not going to do the whole notation. I just want to practice the inequality. Okay, so subtracting, not much different. Subtracting in between. We can't simplify any of those terms, right? It's going to be the same domain. All of these will be the same domain, except perhaps the division. Okay. Now, next one, multiplying, that would be root x plus 3 times root 3 minus x. Okay. Now, you could, if you're multiplying two radicals together, you can multiply the radicands, what's inside. So we can expand this out. That would be 3x minus x squared plus 9 minus 3x. And so that ends up giving us -x squared plus 9, or 9 minus x squared as your radicand. Okay, not much else you can do from there. Okay. If you hadn't checked at the beginning, and say you just were given this, think about that as the absolute value of -x squared plus 9. So this is just a little bit of an aside. If we were to graph that parabola, it would have a y-intercept of 9 and open down, vertex at 9 as well. Okay, then when we take the square root of it, remember we can't take the square root on here. This would become down here, the ones would stay. That would be a little bit higher. This would be here, this would be here. And then you would approach, so square root of 0 is 0. So you'd have basically something like that. So between -3 and positive, right, if you were to graph that. You can't take the root of an integer. So any parts that would be underneath will not be included. And then last is the division. Okay. Again, nothing you can do because they're not common factors. Okay. You could rationalize, but we're not going to. We'll just leave it like that. It's going to be this. Except, remember, we can't have 0 in the denominator. So what value of x makes that 0? 3. 3 is part of that. So now I just show it as less than 3, not equal to. It can still be equal to -3, but not 3. So be aware of that. Okay, so to summarize the domain of two functions, it says, given two functions f and g, the domain of their sum, difference, or product are all the values of x that are common to both. Right? Can't be in one and not the other. Then when we get to the quotient, the division, the domain is all the values of x that are common, but it excludes those that make the denominator 0. And the denominator in this case is g. So it excludes the values where g of x equals 0. Okay. So another set of quadratics in this case, so polynomial functions. Domains of polynomials are the easiest, right? It's just all real numbers. Notice how we've only been caring about the domains. We really don't end up finding the range when we're just doing operations. Okay. And then write the equation for g of x divided by f of x. Okay, it's a good review for Math 10. So you do that and you factor it, please. Okay, so you want to factor numerator and denominator. We'll divide out any common factors. Okay, so the domain for this function now is all real numbers except whatever numbers made the denominator equal to 0. So you have to look back at the form before you divide anything out. So here it's going to be everything except positive or negative 4. Okay. In terms of the domain, I guess proper form here. I'll put it in proper form. Question? Okay. All right, flip over to the next page. Okay, so now we're given graphs, not necessarily the function, or the equation of the function, but we're going to come up with it. You don't necessarily have to. So if you're given the graph, you can answer a whole bunch of questions without knowing the equation of it, as long as those questions involve being given the x value. Okay? So for example, before I even do the first part here, if I look underneath, it says when we're adding functions, state the value of f plus g of -4. Well, f is here, so you're going to look where x is -4. What's y? It's 0. Plus what g of -4 is. So here's g, -4. What's the y value there? So g of -4, you're looking for the y value. F of -4, you're looking for the y value. That's -6. So overall, your answer is -6. You didn't need the equation. Okay. Then f plus g of -2. Well, f of -2 is -2. G of -2, notice that that's where they intersect. So they are going to have the same value. So that's equal to -4. And then f plus g of 0. So f of 0 is -4. G of 0 is 2. Okay, use the values above to state 3 points. So that would be on the graph of the sum of the two functions. So that first point would be -4 for x, -6 for y. Second point would be -2 for x, -4 for y. Third point would be 0 for x, -2 for y. Okay. Let's go back and find the equations because we're going to need them in a sec. So state the equation in the domain of y equals f of x. So this is a linear function. The y-intercept is -2. Take 2 nice points. The slope would be -1 over 1, which is -1. So this would be f of x equals, so I use function notation, -x minus 4. And that's all real numbers, right? Because it's a linear function. Notice how when we graphed it, we put arrows on the end. So we didn't restrict it at all. We said all real numbers. For g, y-intercept is 2. Choose another point. From left to right, I'm going up 2 to the right 1. So g of x is 2x plus 2. And again, all real numbers. Okay, so it says plot these points on the grid below and a few more points using the graph. So, okay, so now we're going back to our points here. This we copied out for you, those 2 lines for f and g. We're going to plot -4, -6, -2, -4, 0, -2. And you'll notice that we get a line, right? If you're adding 2 lines together, you still get a line. It's not just suddenly going to become a quadratic because you're not multiplying the x's together. That would be the only way. Join these up. Okay. Okay. So take a look. What's the equation of that line? Okay, well, it's got a y-intercept of 2. And what's the slope? Up 2 to the right 2, so it's actually a slope of 1. So x, so it's got a y-intercept of -2. Okay. And then does the equation match the graph you drew? Oh, well, I did a little switch around. But in any case, if I look back here and add these together, so I get -x plus 2x is x, -4 plus 2 is -2. So exactly the same, so yes. And the domain, it's a line, so still all real numbers. Now, let's look at division of those two linear functions. So it says state the value of f over g at -4. So notice how we found here, it's still the same x value. So f was 0, g was -6. We're dividing 0 by anything is 0. -2 dividing, so that would be -2 divided by -2, which is 1. -4 divided by 2 is -2. So use the values above to state 3 points that would lie. So just like we did in the previous part, so that would be -4, 0, -2, 1, and 0, -2. Okay, and plot those. Then it asks, what is f over g at -1? So f is -3, g is 0. So -3 over 0 is undefined. So that's where we would get an asymptote. Okay. Try to plot a few more points using the graphs. So we need a little bit over here, right? So let's say at 1, we have f is what? -5 divided by 4 is -1.25, so kind of about there. If we said, okay, at x equals -0.5, then our f is -3.5 divided by 1 is -3.5, so that stays about there. So it's going to be those two arms. It's never going to cross over, be positive, because these y values are always negative to the right of the asymptote. Then here, let's say, okay, -1.5. So our f is -2.5 divided by -1 is positive 2.5, so about there. Okay, and then this does touch at 0 there. You could find another point, let's say, at -5. So your f is 1 divided by -8. So that's -8 there.
Did I get, what did I do there? That was supposed to be, so this one is actually, are we going to get even smaller than that? We can't actually tell. I was a little bit off on this. Our asymptote might be at -1. So I was a little off from what I can tell here, because I should have gone through that -1.25. So right now, graph is cut off. Maybe it does, but we can just stop it there. Just make sure that we don't assume too much. Okay. So when we do our equation, so our f is -x minus 4 over 2x plus 2. Okay. And then you can factor out the 2, but nothing, and the negative, but nothing's going to actually simplify. So you can show this as -x plus 4 over 2 times x plus 1. Okay. And so you can see that x cannot be equal to -1, and that's what we got. So domain will be x not equal to -1. And just so you know, actually I can tell, because I've learned more that you will learn next year as well, what the horizontal asymptote would actually be -1/2. But for right now, you don't need to know that, right? We're not going to ask you the range. Okay? Now we've got a quadratic and a linear, but a restricted domain to the linear. All right, so it says state the domain of, state the equation for f of x in simplified form. Okay, so you might get it in vertex form, and then you'll have to expand out. You might get it in factored form, and then you expand out. Doesn't matter. You decide which way. I'd probably use vertex form. So f of x will equal a times x minus 3 squared plus 4. And then my a value, you can find by inspection. 1 unit over is 1 down. So that's going to be -1, which we only just show as a negative. Okay, now expand those out. So while you're expanding, you just got to make the